In this video we're going to cover surface milling using the Shapeoko desktop milling machine. And what we see here is a milled surface, and what it represents is skin under a microscope. So I had an image, a black and white image of skin under a microscope, and I brought it into RINO and used height fields to create this surface. And one of the things that we want to cover in this video is roughing and finishing passes. Typically when you're machining a surface, you'll do a roughing pass, which has big step downs and big step overs, and the surface will look something like we have in this area. And then you'll run another pass called a finishing pass, where the step over and step down is much closer together and you get a finer surface. And here's an image of one that was actually milled on the Shapeoko. So let's first talk about the type of end mill that we need to use. Now remember, you can't use a drill bit. You have to use an end mill, which is specially designed for milling from side to side. A drill bit is designed for going up and down. So I'm here at inventables.com, and I'm going under bits and tools, and I'm going under milling bits. And the Shapeoko uses end mills that have a shank diameter of 1/8 of an inch. So for milling a surface, you use what's called a ball end mill. Now what exactly does a ball end mill look like? Well, I did a Google search, and here you see the images that show up. So it has a round bottom versus this is not a ball mill, this is a flat mill. So for milling surfaces, you need to use a ball end mill. And the one that we're using from Inventables, it has a cutting length of 0.87 inches. So that's important to know when we set up our ball end mill in RhinoCam. So let's head over to RINO to set up our machining passes. So let's start with the units. We want to make sure that we're working in the correct units. So I'm going to go to File, New, and I'm going to choose Small Objects Inches. Okay, this is for making something smaller than a truck. So we're definitely working smaller than a truck. And when we look at the tolerance, we're working in 3 decimal places, or 1/1000th of an inch. Okay, we'll go ahead and work in the perspective view. And the first thing that I'm going to set up is the size of my stock that I'm going to be milling. And in this case, I'm using 1 inch thick MDF. 1 inch is the nominal dimension, not the actual, and we'll talk about that in a little bit. So I'm going to ultimately have a piece of stock that is 4 inches wide by 5 inches long. But I'm going to need a little extra space, and we'll talk about that again as we move forward. So I'm going to start with a rectangle from 0, 0, 0, and it's going to be 4 inches wide, so 4 comma, and I'm going to make it 5 1/4 long, so 1/4 inch more than I need, so 5.25. Okay, so there's my rectangle. So what we need to do next is copy this rectangle vertically, and we need to copy it down the actual dimension of the MDF that we're going to be milling. So I'm going to select it and type in copy, enter, and choose vertical equals yes, and point to copy from. I'm just going to pick an endpoint, and I'm going to copy it down negative 0.983. And what 0.983 represents is that's the actual dimension of the MDF that I'm milling. Even though we call it 1 inch, 1 inch is the nominal dimension. So I took a pair of digital calipers and I measured the MDF, and I found the smallest depth of it, and I used that value. So I can just hit enter and hit escape, and there's the thickness of my stock. The next thing I want to do is I just want to double check these distances. I want to make sure that this is 4 inches and this is 5.25 inches and that the height is 0.983. Okay, so everything's correct. And I'm going to go ahead and paste in the surface that I'm going to be milling. And if I change that to a shaded view, what you'll see is I've left a 1/4 inch of space between the corner and the start of my surface. I've left 1/4 inch because where you see this XYZ axis, that's going to be 0, 0, 0. So I don't want to mill that area of the MDF. I don't want to mill that away. I'm going to need that corner because I'm running 2 passes. I'm running a roughing pass and then I'm going to run a finishing pass. So I have to make sure that I don't mill away 0, 0, 0. So I've just left myself 1/4 of an inch. Okay, so let's go ahead and set up our roughing and finishing passes. So first thing I want to do is just check, make sure I'm using the right machine, a 3-axis, the right post processor, which is flash cut pre-6 inch. I'm going to go ahead and set up my work 0, and that's going to be 0, 0, 0 XYZ, and I'm going to generate that. And the first pass that I'm going to make is going to be found under 3-axis, and I'm going to use a parallel finishing. Now I don't have a parallel roughing, so I need to make a pseudo roughing pass. So I'm going to choose parallel finishing. And what's different when we're milling surfaces is I don't necessarily need to select a drive containment region. If I'm milling the entire surface, I would leave this empty. If I want to mill a specific area of the surface, I would select a drive containment region. So it tells the Shapeoko what portion of the surface to mill. So I'm going to mill the whole surface. I don't need any drive containment regions. The next thing that I'm going to set up is my tool. And I'll go to Edit, Create, Select Tool. And I'm going to call this one Ball Mill. Now Ball Mill was the default tool. So this one's going to be Ball Mill 1/8 inch. And this is going to be my rough. Okay, because I'm going to set up my feeds and speeds for my roughing, which are going to be slower. My feed rate is going to be slower than with my finishing pass. Okay, so the tool diameter is 1/8 of an inch, so 0.125, and the tool length is about 1.25, and that's after I've inserted it into the collet on the rotary tool. That's about how much I have left. My shoulder length can be the same as my tool length. My flute length, so my cutting length, that's something we saw a few minutes ago over at Inventables. It was 0.87 inches was the flute length. The holder diameter, so this is the collet that holds the end mill, that can be 0.5 inches, and the holder length can also be 0.5. And now we have a good representation of our tool. And if I go over to feeds and speeds, when we're milling wood, we're going to go slower than when we were milling acrylic. And we're going to start with a RPM of 10,000. And when we're milling on the Shapeoko, we have to control the spindle speed manually. So we're not setting it to the maximum of the rotary tool. What worked well was about halfway between 4 and 5, the setting of 4 and 5. Our plunge, approach, and engage. Now on this roughing pass, we're going to go slower. We're going to go 30 inches per minute for the plunge, approach, and engage. And we're going to go 50 for the cut, retract, and departure. And when we come back to do the finishing pass, we can go faster. I noticed I had 1.8 in here instead of 1/8. So I'm going to go ahead and just double check, make sure my tool diameter is 0.125, 1/8 of an inch. And I'll go ahead and click on, in this case I can just save edits to tool, click OK. Just choosing my ball mill 1/8 inch rough. Okay, next are my feeds and speeds, and I just want to make sure that those carry over. If they didn't carry over, I can always click on load from tool. Okay, going to the top row, I'm going to set my clearance plane, and I like to use an absolute Z value. I like to get as close to that surface as possible so I can save time when I'm milling. So I'm going to click on absolute Z value, and I'm going to go ahead and lower that down. 0.05 will be fine. Okay, now my cut parameters. So again, I keep mentioning roughing and finishing. So my roughing pass, which is what we're setting up now, I'm going to leave some stock. I'm going to leave some wood. I'm not going to mill it all the way down to this surface. I'm going to leave about 0.02 inches of stock. Next, I need to set my step over. So this is the end mill moving from side to side. What is the distance we want it to move with each pass? So I don't like to use the tool diameter. A couple of reasons. I might have made a mistake in the tool diameter when I entered it in a few steps back. And I like to actually set the step over distance that I'm going to use. So I'm going to choose distance versus the tool diameter. Now the rule of thumb is 50% of the tool diameter on a roughing pass. Now with the Shapeoko, we can't use large end mills, large radius end mills. We have to use small radius end mills. So it takes a lot longer to mill a surface versus on a large scale CNC machine where you can use end mills with larger radii. So I'm going to be a little unorthodox, and I'm going to use 5/64 of an inch. Okay, it's about 3/64 smaller than the diameter of the end mill. It's about 62.5% of the tool diameter. So I have to put that in decimals. So that's 0.078125. That's going to be my step over. So it's a pretty big step over for milling with a 1/8 inch end mill. Okay, next I'm going to set my step down. How much of the material am I going to take away vertically? I can't just go in here and just have it mill to the bottom of this surface. It's going to break the end mill for sure. So I'm going to insert multiple step down Z cuts, and again the rule of thumb for a roughing pass is about 50% of the diameter, and I'm going to go ahead and step down, again unorthodox. I'm going to step down the full 1/8 of an inch, and this works for me because my feeds are a lot slower than I would typically use. So I'm going to go ahead and step down the full 1/8 inch, so 0.125. Entry and exit I can leave as the default, and I'm going to go ahead and click on generate. Okay, so I don't have my toolpath visibility on, and I can go ahead and turn that on. So here we see our step over lines that are 5/64 of an inch apart, and then it's going to step down in multiple levels, and these are 1/8 of an inch apart. So it looks like it has to step down about 1, 2, 3, 4, 5 to get to the lowest portion. This one might be 6, where it dips down even lower. Okay, now I haven't set up my stock yet, So I'm going to go ahead and double click on stock, and I'm going to make sure that my 0, 0, 0 is set, so that's 0, 0, and make sure that it's using the actual depth of the MDF, which is 0.983, and the dimensions I'm going to make are 4 by 5.25, height is 0.983, and I can click OK to exit out of the stock. And I'm going to go ahead and rename this, because this is not my finishing, and that can be confusing. This is my roughing. So I'm going to rename this, and I'm going to call it roughing. And I'm going to go ahead and I'm going to simulate this just by right clicking and choosing simulate. And I'm going to uncheck simulate by moves so we can see this going slower. So what this parallel roughing is, and also parallel finishing, is the end mill is going to move side to side. And you saw it started in the lower left, and it's just going side to side and then using the step over distance and moving side to side, step over, side to side, step over, side to side, step over, while it's also stepping down into the material. So right now it's on its, looks like it's on its second step down. It did the first one real quickly when we first started. So I can check back on simulate by moves, and it's going to go a lot faster. And I can also turn off the toolpath visibility. So you see the resolution, I'll call it, is not very fine. It's rough. It's not a finished piece. And we can see the step overs and the step down. And I'll just go ahead and make that go a little quicker. Okay, so that is our roughing pass. Now I can set up our finishing pass. So I'm going to go back over the program. I'm going to 3-axis, and I'm going to choose parallel finishing. Okay, again, I don't need any drive containment regions. We'll come back to this a little bit later. My tool, I'm going to make a new tool, a ball mill 1/8 inch finish, because I'm going to set my feeds and speeds, not my speed, but my feeds. I'm going to set my feeds faster because I'm going to be taking away a lot less of the material. I only need to mill away that little bit of stock, that 0.02 inches of stock that I left. So I'm going to go and edit, create select tool, and I'm going to call this one finish. Okay, the size of the tool is exactly the same as it was with the rough, but what's going to be different are my feeds and speeds. So I can go faster. My plunge, approach, and engage, I can go at about 75 inches per minute, and my cut, retract, and departure, I can go at 100. And I want to make sure that I save this as a new tool. Now it's going to give me an error because I didn't set this to tool number 2. It's still set to tool number 1, so the tool number is repeated. Do you want to use a non-repeated tool number? Yes. Okay, so that's my ball mill 1/8 inch finish. I can click OK, and I'm going to choose that one. Go over to my feeds and speeds, make sure that those are showing up, the faster feed rate. Go to my clearance plane, it should remember from our last settings. Cut parameters. Now in this case I'm not leaving any stock. This is my finish pass. Okay, now my step over. So now I can step over much closer than I did in the roughing pass. In the roughing pass, we were stepping over 5/64. Now I'm going to lower that step down to 1/16 of an inch, so 0.0625. Now this value can be much smaller. It depends on what kind of surface quality you want in the end, what kind of resolution. If you want it very fine, this could be 1/64 of an inch. It's just going to take longer to mill, but you're going to have better surface quality. So we'll start here with 1/16 of an inch step over. And I'm going over to my Z containment, and I'm not stepping down. I don't have to step down now because I've already milled away most of the surface in my roughing pass. I only have that 0.02 of an inch left over, so I don't want to step down. Entry and exit is all default. I can click on generate, turn on my toolpath visibility. Okay, so there's no step downs. Okay, because it's already been milled away. When I go over to simulate and turn off the toolpath, this is what we're starting with before we run our finishing pass. So go over to parallel finishing and go ahead and right click and simulate. I'm going to uncheck the simulate by moves. So here's that 0.02 of an inch that it's actually milling away. And you see it's more fine than the roughing pass. Now let's go ahead and look at making that even finer, just so you can see. So let's actually finish the simulate. Okay, so let's look at the difference between these two. Here is the rough, and here is the finish. So if that's not fine enough, we can go even finer. And all that requires is going into our parallel finishing, just by double clicking on it, and going over to our cut parameters and making this value smaller. And I think a better way to do that, instead of making this value smaller, is let's make another parallel finishing so that we can compare these two. So when we go to simulate, we'll have our rough, we'll have finishing, and I'll make another one with a better resolution where the step over is actually smaller. So I'm going to rename this. Now when I name this, it's important that I don't put in /. So I'm going to actually just put in my step over. I'm going to spell this out, because if I put in a /, it won't post the G code. So I'm going to this is going to be our 1/16. And I can copy and paste this. I can right click and choose copy, and then right click and paste. Okay, and I'll rename this. This is going to be my 32nd. Okay, so I'll go ahead and change my step over, which is found under cut parameters. I'm going to make that distance. So 1/32 in decimal is 0.03125. And I'll go ahead and generate that. Turn on my toolpath visibility, so you see it's much closer together. There's 1/16 and 1/32. And I will go ahead and simulate. Turn off my toolpath. So I'm going to go ahead and pause that so we can see it's quite a bit finer. You can see the difference there. So I like to post these. Now I have 3 of them. I have a rough, I have a finishing 1/16, and then if I want to go even more, I have 1/32. So I like to post these individually as 3 separate G-code files versus all together as one setup, because I might not be able to do it all at one time. It might take a lot longer than expected. It might crash during one of them. So I like to have these, or more importantly, I might mill a roughing and I don't like the way that it looks. So I'm starting over and I don't have to wait for it to do a finishing pass. So I like to keep these separate. Let's go ahead and finish that. The other thing that I can get an idea of is how long this might take to mill. Now over on the one that I showed you in the image, the roughing took 31 minutes 47 seconds, and then the finishing you see is much quicker because it doesn't have to do the step downs. So that only took about 6 minutes and 10 seconds. So we're looking at about 39 minutes of milling time for this piece, which was 5 1/4 inches deep by 4 1/4 inches wide. Okay, so let's look at these now. So here's the roughing, the 1/16, and the 1/32. And to get an idea of the RhinoCam time, if I go to information, it said it was going to take 21 minutes 40 seconds, and it actually took longer. So we can expect for it to take a little bit longer on the Shapeoko. Let's look at the finishing. So on the finishing 1/16, if I click on that, right click and choose information, that said it was going to take 3.24 minutes, and it actually took 6 minutes and 10 seconds. So in that case it was about twice as long. So you can expect for it to take longer. I'm glad that the roughing didn't take twice as long. Okay, so the last thing that I want to look at is setting up a drive containment. So let's say I don't want to mill this entire surface. I only want to mill a portion of it for testing the step overs, the step downs, taking a look at the design and not having to wait 40 minutes to mill the whole thing. So I'm going to go over to layer, and I have a drive containment layer set up and it's current, and I'm going to draw a rectangle. I'm going to go back over to program. I'm going to draw a rectangle that I'm going to snap to that 0, 0, 0, and it's going to be 1.5 comma 1.5, so 1.5 inches by 1.5 inches. So now I have something that I can use for a drive containment, and I can move that. Let's say I want to mill the area where the dimple is, where it goes down a lot further. So I can actually move that over and I'm going to mill just that area. Okay, so what I would need to do is I would go to all 3 of these and set up the drive containment region. So I'm going to go to parallel roughing, double click, and under machining feature regions I'm going to choose select drive containment regions, and I'm going to go ahead and pick that, and I'm going to hit enter, and I'm going to click on generate. Now if I turn on my tool path, you see it's contained in that region, so it's only milling in that area, and I can do that for these other ones. select drive containment region, click generate, trims the tool path into the drive containment region, and I can do that again for the last one. And I'm going to go ahead and simulate all three of these. Now, one other important note is if I go over to program, here is my geometry. I don't have any other 3D objects in here other than the surface that I'm milling. And that's important because if there's other 3D surfaces or extrusions or whatever, any 3D geometry, whether it's hidden or the layer is off, I found that RhinoCam picks up that geometry and it adds it into the tooling passes. So I always make sure that I don't have any other 3D geometry other than the surface that I'm milling. Okay, so that's it for milling Shapeoko surfaces.